Fetoplacental Doppler ultrasound and fetal echocardiography are carried out to obtain measurements of fetal hemodynamics and cardiac function and structure in IUGR and control fetuses.
This method can help answer key questions in fetal medicine and adult cardiology, such as whether abnormal physiological pressures can lead to disproportionately profound changes in cardiac structure and function later in life.
The implications of this technique extend towards therapy for IUGR, because after surgical induction of IUGR, this model allows sufficient time for the researcher to then administer potential therapies, such as anticoagulants, antioxidants, and glucocorticoids, and then to study their effect on fetal cardiac function, but later in gestation.
The experiment will be demonstrated by Dr. Ryan Hodges, obstetrician and postdoctoral researcher, together with André Lagerche, a cardiologist and postdoctoral researcher, together with Drs. André Miyage and Philip de Koning, obstetricians in training and doctoral researchers at this department.
At GA 30 days, place the rabbit on a warming pad for echocardiographic and ultrasound evaluation using the VisualSonics Vevo 2100 high-resolution micro-ultrasound platform with cardiac and strain analysis software. The system uses the VisualSonics MS250 transducer for data acquisition. It has a center frequency of 21 MHz with a bandwidth of 13 to 24 MHz. The geometric focus is 15 mm, the maximum image width is 23 mm, and the maximum image depth is 30 mm. The footprint is 28 by 5.75 mm. Data is acquired in accordance with the American Society of Echocardiography guidelines and standards for performance of the fetal echocardiogram. After anesthetizing the rabbit, as demonstrated earlier in the video, insert a 24-gauge cannula into a peripheral auricular vein to obtain intravenous access. Maintain anesthesia with a continuous infusion of ketamine and xylazine in normal saline via a syringe pump at 40 milliliters per hour. Secure a 3-way tap and attach a 5 milliliter syringe of rescue anesthesia and deliver a subcutaneous injection of buprenorphine. Apply a mask and deliver 2 liters per minute of oxygen and place a pulse oximeter on the second and third toe. Once the abdomen has been opened, as demonstrated earlier, and the rabbit is placed in a lateral position facing towards the researcher, expose a single gestational sac and place it on gauze irrigated with warm saline. To avoid environmental and iatrogenic effects on fetal cardiac function, immediately begin ultrasound examination. Working in a systematic and efficient manner at the level of the lateral 4-chamber view, record a B-mode cineloop of at least 5 cardiac cycles to determine strain, strain rate, velocity, and displacement. Then, still working in this standard view, obtain M-mode echocardiography indices. Next, at the level of the apical 4-chamber view, repeat the B-mode cineloop and use M-mode echocardiography to assess tricuspid and mitral annular plane systolic excursion and longitudinal strain and strain rate. This apical view also permits assessment of valvular flow velocity waveforms and the modified myocardial performance index. To obtain flow velocity waveforms, or FVW, of the umbilical artery, use color Doppler to locate the umbilical vessels and place the pulse Doppler sample gate over the umbilical artery on a free loop of umbilical cord. Once the circle of Willis is located, find the cerebral artery FVW by placing the pulse Doppler sample gate just beyond the origin of the middle cerebral artery, or MCA. To obtain the ductus venosus, or DV FVW, Using either a sagittal or transverse view of the fetus, place the pulse Doppler sample gate at the proximal portion of the DV, where it originates from the intrahepatic umbilical vein. To analyze the data offline, use the VisualSonics cardiac package for calculating M-mode echocardiography indices, and for strain analysis, use the Vevo strain algorithm as previously described. Finally, using the VisualSonics cardiovascular analysis software, calculate the pulsatility index, or PI.
While attempting this procedure, it is important to remember the invasive nature of experimental fetal surgery. The uterus and the fetus must be handled with care. All of the measures we have described to reduce uterine activity and prevent fetal bradycardia during echocardiography are all highly recommended to ensure that you'll have successful experiments.
Following this procedure, other methods like various tissue analyses from the placental and fetal tissues can be performed in order to answer additional questions like what are the fundamental mechanisms involved in fetal cardiac adaptations in IGR.
After having watched this video, you should have an idea how to induce fetal growth restriction in the rabbit model and how to assess by ultrasound using Doppler and fetal echocardiography its effects.